just a few tidbits here. Speaking of Penn State, some of you know that I'm a professor, have been a professor at Penn State since 1989. And I was going to retire this July 1st, but when the COVID hit and they said, we're definitely going to be online in the fall. And I was online at the end of last spring and could work from home. I decided that I won't retire and put in another year and help out the university and so forth. So hopefully next summer I'm going to retire and then put full effort into this station we're building on what we call the Magic Mountain, or known as Camp Kilowatt here east of State College. Okay, so I had about 1,000 topics I was going to talk about, but I sort of zoomed it down, and hopefully the time will come out okay. And when I start seeing everybody sleeping, I know I went too long, but my friend in Puerto Rico, Angel, says I have the gift of gab, so I hopefully won't go too long tonight. But anyway, I decided to pull out some designs from past years that I thought might be interest to people, and then also some current things we're working on this mountain, building the station up, and some other stuff. So some sort of neat surprises and things. So anyway, I am WA3FET, and for about 20 years, we had a station here in State College area. Then we used the Penn State call sign, K3 Charlie Radio. The main operator all those years was Alex, Lima Zulu 4 Alpha X-ray. And Alex usually did pretty good, usually in the top 3 or 5 in almost all the contests. He did have the WPX CW single op high power record, and that was broken this year, but he still has the CQ worldwide single op high power CW record. So who knows what will happen in October. But anyway, for WPX, we use the call KC3R. And I think that's the call that we'll probably use when we get this station on the mountain finished. So that might be the future call sign, KC3R. As you know, I've done a lot of work over the years in Arecibo, Puerto Rico. I've given talks here before on Arecibo. And down there, I'm known as Senor Rompe Todo. And anybody that speaks Spanish will have a chuckle, because that means Senor break everything. And of course, my name, you get the idea. I also built a station there that lasted for about 20 years. And I'm going to talk a little bit about that station and why it works so good, I believe, on top of a mountain in Puerto Rico on the north coast there. And it was just the perfect mount. I used to go to Puerto Rico a lot as a student, and I always drove by this place and thought, wow, this would be a neat place. And fortunately, I married a girl from there, and her uncle owned the property. So I was able to get the property and build the station. But then this other thing came along called Hurricane Maria back in 2017, and that's all she wrote. That whole thing went down. It did last through Hurricane Georges, which was another big one back in 1998. Okay, so let's move on here. It's just a coincidence. I thought I'd show this. Trey, who N5KO, Trey just sent me an email this past week and said, oh, he was going through his old QSTs and he found this picture in the QST. So he sent it out to everybody shown in the picture. And Dave, who's W6NL now, used to be W6QHF, Dave Leeson, he actually had the original picture. So we got it and put it together. But anyway, this is sort of neat to read. How would you like to have this crew show up for your next antenna raising party? That's me, 1994. Of course, I don't look any different, right? And that's Brian Beasley, who wrote YO and MN and AO, and then he got mad at all the mainly Europeans stealing all the software and hacking into it, and he just got out of the whole business, which was a shame because he really created some fantastic stuff. That's Roy Llewellyn, who still is in the business and has Easy Neck. And of course, Dave, who was the founder of a company called California Microwave. And also for many, many years now, he's been a professor, basically volunteering his time as a professor at Stanford. And that's Trey. And Trey always gets the question, why is he in this picture? But he was there to operate a contest that day. So he got in the picture too. So I just thought maybe that bring back some memories of if you might remember seeing that picture back in 1994. Okay, so let's get on to the talk tonight. I think this list started out with about maybe 20 some topics, and I said, this isn't going to work. And I don't know if even this is going to work. We'll see how we do on time. But anyway, I picked out some topics I thought would be sort of pretty interesting that go back in history and up to the present. NP4A. NP4A is Pedro Pizza. He used to be KP4 Atlantic Standard Time way back. And back in 1988, and I was had worked at Lawrence Livermore Labs on the numerical electromagnetic code NEC. And I was at the Naval Postgraduate School for a year there as a professor. Pedro said, could we build an 80-meter beam? There weren't too many 80-meter beams around in those days. There was I5NPH, had an 80-meter beam, OH1RY. And some of you may remember W2HCW. And Pete is now W6KW, had the KLM. And so anyway, there were a few. I think Chuck, K1KW, WA1EKV had an 80-meter beam up for a while too. But usually they didn't stay up, okay? They maybe stayed up for a little while and that was it. Well, anyway, Pedro's was it was probably the 80-meter beam of all 80-meter beams. And he really designed this thing. It was never going to come down with a hurricane, and it's amazing. I'll show some pictures of it, but it did come down with a hurricane, and it's a very interesting story how it came down. It was only used in a couple contests. The main one was from Jeff, K1ZM went there. I'm going to omit somebody. There we go. And they used the call NP4A 1988 CQ Worldwide 80-meter single band, and they really set a record with this thing. And he worked like 200 JAs or something on 80 meters. It was really unbelievable high score for that time frame. And then Pedro, I think, tried phone and he lost power, and he didn't get quite as good of a score, but then it came down. That was pretty much it. Anyway, I'm going to talk about that. And then also a friend of mine, you all may know Tom, KHCX. Tom has what's called Ham Gallery, and he's the main photographer at Dayton. If your picture is not in his Ham Gallery, you really haven't been to Dayton. And anyway, he had a high gain 205 laying in the garage, and he was going to put that up, and he just called me and said, would there be any way to modify this to make it an OWA, which OWA stands for optimized wideband antenna, and that's something I came up with some years ago, and OWAs are being used a lot these days. And so anyway, I worked on it and tried not to change too much. And he had to buy a little bit of aluminum and move the elements, and it really came out nice. And he said it's just working unbelievable. So I thought I'd talk about that. And then I did mention I have this station in Puerto Rico, and I thought I'd show some HFTA analysis of that station, just to show why that station was so good there, and why it won so many contests worldwide, and mainly sweepstakes. You may recall, won about 10 years in a row. And I think everybody was getting tired of this call being the winner every year. That's Angel's Call. We used Angel's Call for that. Well, I'm admitting people like crazy here in the waiting room. Okay, and then I want to get to what we call Camp Kilowatt, or Camp K for short. Some people that I've talked to on a regular basis have called it the Magic Mountain, because we just put up an inverted V up there, and it's getting almost the same signal the K3LR is getting, okay, on 40 meters with his 3 Yagis in the Middle East. So we can't wait to put some real Yagis up and see what it will do. And we finally put the first Yagi up on 20 meters, and we get a lot of rime and ice up there. And so I came up with some new design. I call it the OWA-ice model, where it goes way, way up above the band. And as you know, when you get ice on an antenna, it shifts the frequency down lower. And so this antenna goes almost to 15 megahertz. Okay, so any ice we get, it should not affect, and we should be able to operate. But it had to be made super, super big. And I'll show it. I have some drone pictures. It has 2 3-inch booms. Each element weighs about 35 to 40 pounds. And the whole antenna, 20 meters, 52-foot boom, weighs 450 pounds. Okay, just the 20 meter. And we got K0XG rings on the tower. We put the middle one up first, because that's where, if you phase them all together, that's the effective height. Did a lot of HFTA. And we're planning to put 2 more up on that tower. And it's a solid round, member super tower. In fact, N3 Echo Bravo, who owns the mountain, he actually has double legs on the tower. He actually had extra solid round legs welded to part of the tower, and had it galvanized and so forth. You'll see that. And we decided we don't want to interfere with the 20s, but we wanted to put something up on 6 meters. So I said, why don't we make a scale model of the first OWA Yagi, which I did for Tim Duffy. K3LR was a 4-element 40, which a lot of people have used since. And so we made a scale model on 6 meters of this, and you'll see that. And it's pretty amazing, the bandwidth and the way it's been working up there. If I have enough time, I got a little surprise video of a super antenna. And then if I have enough time, I want to talk a little bit about something some of us started back in March when the COVID hit. And it just happened to be a lot of what we call the big guns, K3LR, and I can go through a whole list here of got on, and we've been getting on 40 and 20 pretty much every day since COVID. And we've been working stations all over the world on 20 meters every night that we get on there. We get into India, Thailand, deep into Asiatic Russia, and so forth. And let me omit somebody here. And it's amazing. So we called it the Big Gun Friendship Net. In a way, I don't like that big gun, because we don't really care who gets in. It can be little guns. But anyway, that's what we call it, the BGFN. And if I have time, I'll show just a couple, just one little video that shows the signal with a dipole from this mountain in Pennsylvania compared to K3LR with 3 Yagis aiming to the Middle East. Okay, so I'm going to show something here, a couple videos. The first video, and I hope it will work, it's going to show pretty bad photography of 1988 of NP4A's station. And And then it's all in Spanish, so I'm not gonna keep it going because unless you speak Spanish, you may not understand it completely, but then I'll go through it. But I thought it'd be neat to show the video. So let me minimize this. Let's see here. Oh, nope, we don't want to do that. Okay, so I'm going to minimize this. And I just remembered I got to stop the sharing and then come back in because I got to set the sound on it. So let's do this and share computer sound. Okay. Okay, I think this will work. Let's try it here. Can you hear this? And see it? Do you see the video and hear it, everybody? Guess you're all muted.
Yes, looks fine.
Great, okay, thanks.
Okay, saludos a todos. Mi nombre es Pedro Pisa Hijo.
There's the 80-meter beam up here.
Y ustedes están viendo cómo era mi finca de antenas para los años 1988. La mano izquierda, torre donde había 30 decibeles sobre 9.
He's showing he gets into Europe.
La giraba 30 días y normalmente
and then here's Hurricane Hugo.
El viento sopla fuertemente. Fue un estilo que nunca las 4 y una para el sistema de material, la materia prima y construir las poleas y todo lo que se usó en la parte mecánica de esta antena.
Okay, so let me bring the presentation back. Okay, everybody still see the presentation? Okay. Yep, good, thumbs up. Okay, so anyway, this is the 80-meter beam. It's using, it's 82-foot boom, and it uses AB 105, if people are familiar with that old military type surplus tower. So that boom's made out of AB 105. And it's unique in that right here at the center, there's pivots and there's cables on it. So the boom, each boom can rotate down and nest against the tower, okay? The tower is a old ship-to-shore tower that Pedro got as they were taking it down, and they put it back up here. It's 160 feet high. And then as he nests these booms down against that tower, the elements can rotate. They have rotators at the ends here, and so you can rotate the elements so it goes along the boom. So when it comes down, everything will be nested against the tower when a hurricane comes. The tower was self-supporting, but he added guys to it, okay? And so that was to really make sure, and he beefed up the tower too. He added a lot of extra girder work and so forth. So it was really a tremendous undertaking, okay? Anyway, this is the base of the tower. It's not triangular, it's actually four-sided tower. You can see it's probably about 20 feet on a side there or so. Pretty big, and it was self-supporting. There's Pedro back in '88 on, I guess, a thrust bearing or something for this thing. And this is Pedro's farmhouse up there. And as you can see, he was really pretty neat there about how he ran all his cables and everything for the contest station. I don't know if anybody has a similar looking setup like this, but Tim Duffy would cringe, I guess. And then he lives way up about 3,000 feet, almost to the highest point at the center of Puerto Rico. From his site, you can see the Atlantic Ocean to the north, and you see the Caribbean Sea to the south. It's just an ideal location. This is looking towards Europe, and it is just unbelievable, that site, okay? Anybody else that puts anything up down below, they're like maybe S9, and Pedro puts the same thing up. He's like 20 over. Okay. So really tremendous. You notice his guides, he didn't use Philly strand. He really broke all the stuff up with insulators. And so when you drive up to this place, when he had 7 towers, it's just a sky of insulators. Okay. Well, here's some pictures of the construction of the 80-meter beam. There's the AB105 tower down here. There's actually the end of the boom, and you see how he mounted these rotating parasitic elements on there. So that could rotate and go right along the boom when he would nest the booms against the tower. Here's an element. You can see it's sort of saggy when it doesn't have all the trusses on it. And there they are standing. You get an idea. That's how big this thing is. Okay. There's one of the ends also that would support a parasitic element. There's somebody sitting on one of the booms there, AB105. Pretty amazing. By the way, this is Whiskey Papa 4 Lima. He was the mechanical engineer. His degree was in mechanical engineering. Pedro's degree is in electrical engineering, and mine's electrical. And so I did all the antenna design, and Alberto did all of the mechanical design with Pedro. Here's just showing adjusting the trusses for the parasitic elements. Here's somebody up on the tower with one of the elements going up, and you can see it here. He's actually sitting on the element, okay, riding it up, and it's unbelievable. And he had a great big rotator and a mast that went down about 50 feet down from the top of the tower, and this is what rotated the antenna. He used a Volkswagen engine out of a Beetle, and that was through a huge gear reduction, and that's what would actually nest the boom and raise the boom up. It was all supported by cables. If any of those cables broke, the boom would come down. So that's how the boom was supported. Okay, this is showing the nesting, how it worked. You can see this element is being rotated at the end. There's actually, if you look here, these little dots, I assume you can see my cursor here, these little dots here, those are actually men that are out on the boom, okay, that climbed out here, and before the rotators were put in, they rotated it by hand. And here you can see it, the boom coming down, nested. Also the driven element, it would just come down directly. That's this piece here and this half here. They would just come down against the tower, and you can see the driven elements coming down here. And then here's where everything is starting to get very, very close to being nested right against the tower. So the idea was when a hurricane comes, everything's nested against the tower. The tower's guide very good, and there's no extra wind load and torque up at the top, so everything should stay up. Okay, that was the idea. This is looking up on the boom itself and looking out at a parasitic element. There's the center of an element. You can see how flat, how straight that thing is. And this is the end with all these trusses on the out. Look how no sag at all. It's actually absolutely parallel with the earth. And so it was really, really tremendous. Oh, somebody wants in. There we go. Okay. Let's see. Yeah, so anyway, we found some of the old notes, okay, from the design. Back in 1987 and 88, when I designed this, I had mini neck and neck 2. There was no neck 4. And I was the one that came up and found out that mini neck could handle tapered elements real good, and neck 2 could not. And so that's why we created at Livermore Labs neck 4. which could handle the tapered elements. But mini neck had a problem we found back then, that it seemed to have a frequency shift. So I had to use both of these codes and try to get everything to work properly. And it took a lot of running on computers, and computers weren't so fancy back in those days, and there was not much optimization or anything. But anyway, this was the design that I came up with. This was the reflector. You see, it started out at 4 inches and went to 1 7/8, and then the driven element and the director. Okay, and we tried to design it at 3.8 megahertz. So that's where all the action was back in those days. You may remember that Arnold W2HCW always operated on 3802 or so and listened down. So 3800 was sort of where a lot of the people were. To match it, there was no OWA concept then, so I decided to use a hairpin match, and these were just some of the equations I went through to make it come out to 50 ohms, and then some modeling, and this was the SWR. It was perfect at 3.8, and about 3.774 or 75, it went up to 2 to 1. So it didn't have much bandwidth. Okay, it went up to about 38, 30 or so. So there wasn't much bandwidth with it, but this is the main region that you wanted. Okay, right in there, and it came out when he built the thing and did everything to the dimensions. He called me up and said it was at 3797 or something. It came out, so it really all worked. Well, today we have more modern computer analysis than the old style mini neck and neck. And one of the codes that I use a lot, it's used a lot in commercial applications, military, and there's other codes similar out there, but this one's called FICO, and it can do just about anything. Okay, it can model metal plates, things made out of metal surfaces. It can model the dielectric of glass and material, and so it's very, very sophisticated. It has many, many techniques of making things work out faster. It has a huge amount of optimizers built in to come up with the best antenna designs. And so all the designs I do today, I usually will use NEC 4 still, and then I use FICO to really check, because I believe FICO actually is even a little bit better than NEC 4, okay? And so I really trust it a lot. Well, here's some modern analysis. Probably can't see this too good, but there's just a driven element that was up 160 feet. That's a driven element with all the tapered telescoping sections. And this is showing, I guess in this yellow, here's FICO, and NEC 4 is blue. And on the resistive part, it's like a perfect match. There's like no difference between FICO and NEC 4. On the imaginary part, which is actually more critical for designing the antenna and getting everything correct in frequency, there's a slight shift to maybe 20 kilohertz or so, but 20 kilohertz on 80 meters, that's not a real big amount. And so I'd say these codes are green. If I made the plot cover much more of the band, you'd see them pretty much lined up on top of each other. But there is a little bit of shift. We've seen this shift as we go higher in frequency, like on 20 meters, it might be closer to 50 kilohertz or something. And with something like an OWA Yagi that goes way outside the band, it's not that critical, okay? Either NEC 4 or FICO, you could be happy with either model. But if you want to be right on, you'd want to use something like this FICO. But unfortunately, it's somebody else wants in there. It's not available at a cheap price, depending on what computers you have it on, and whether you're the military or educational, it can cost up to like $75,000. So, you know, not too many people are going to get this. Unfortunately, at Penn State, we get it for almost free because the companies want all the students to learn on their software. Anyway, this is with FICO. It shows the response here. And the 2-to-1 is right here, about 3.4 megahertz. And it was about 2-to-1 right here, about 3825. Okay, I'm sorry, not 3.4, 3.74. 3740 was 2-to-1, and 3825 was the high part, and then it was a perfect match with the hairpin right there. Here is the pattern at 3790, and if you look here, the gain was about 13.5 dBi, so that's a pretty substantial gain for a 3-element Yagi, and these side lobes are down about 35 to 40 dB. Okay, so it's way down, and that makes me really happy that the new kind of modeling gave really very close to what I modeled back in those days with much more primitive modeling. So I felt pretty good about this, and of course I knew the antenna worked because I was in California at the time, and Jeff was you know, running the contest, and Pedro called me on the phone and said, "Can you hear the signal?" And he's aiming at Europe now. And I said, "I don't hear anything. I can't hear anything." And he told Jeff, "Just turn the antenna to California real quick so Jim can hear it during the contest." And he turned it, and it went way up to like 20/9 or something. It was unbelievable. So I knew the antenna really worked. Here's the azimuth pattern here. So anyway, that's pretty much on that antenna now. This is the 3D pattern that FICO produced on it. So you can see all this back lobe stuff is way down, okay? Had a little bit of a higher angle lobe, but that didn't matter. Anyway, what happened to this antenna? Hurricane Hugo came along in 1988, and or was it 89, I guess. Yeah, I'm sorry, 1989. And everything was nested. Everything, you know, should have been great. Pedro's sitting inside the house, far from the window, but the windows he could look through, and they're sitting there while the hurricane, and all of a sudden he sees all these guy cables go right along the window, right by the window. And he turned to his wife and he said, "Uh-oh, we just lost the tower." He knew that it was the guy cables from the 80-meter beam. And what happened is instead of putting a regular type anchor, he used like a 2-inch bolt, you know, 2-inch bolt in diameter. And they heated that up and they bent it into a U. So they had a U that went into the anchor, into the cement. And they attached all the anchors to that. Somebody else wants in. And so it looked like it was going to be super strong. It was like at least 2 inches in diameter or something. And they, you know, it formed a U into the cement. And for some reason, they must have did the heat treatment or whatever was wrong with those materials, and it sheared off right at the cement. The bolt just went right off, and that was it. All the guys were on that one bolt, and of course the other guys on the other side pulled the tower over the mountain. So that was the end of that, and that antenna only was up for about a year or less. So that was a sorry day when I got that call, and he said everything, the whole antenna and tower, there was only 10 feet of the tower left above that building, and everything was over the mountain. So that was a really sad day. Oh, gee, these things keep coming up. Every time I give talks to FRC, I keep getting this Penn State stuff in here. Okay, so let's move on. I don't know how we could, if anybody wants to ask any questions, I guess I can wait to the end. Uh, I don't know. I guess that would be okay. Wait to the end, and I'll try to answer. So maybe hold your questions there, or if you'd rather ask questions now, however you want to do it, that's up to you guys. If not, I'll continue here. Okay, the next topic is the high gain 205 CA. Now, if I was there at the meeting, which would be a lot nicer to see everybody around the table and so forth. The tremendous hospitality I get at FRC every time I go there. I think this might be about the 5th or 6th year I've been giving talks there. And I guess GD knows I'll always say yes. And anyway, I'd probably ask how many people have a 205 CA or have had a 205 or know where to get one. And so Tom had one in his garage. Guess it had been sitting there for some years. And I guess he had a TH7 or something like that up there. And he wanted to put a mono band on 20. And so anyway, he asked, could you design it? Now, this is the original diagram. You can download the manual for the 205. And the 205, actually, the CA model was computer optimized, okay? And the thing is, though, it used this, what they call beta match, is similar to that hairpin. And so that made the bandwidth pretty narrow. And the bandwidth for the pattern and so forth, because they didn't have quite the optimization that we have these days and what I've used to do the OWA designs. Anyway, there were 2 settings on this antenna. You had a phone setting and a CW setting. I think some of the older high gain models even had 3 settings. They had like CW, low phone, and high phone. This one had 2, so they got a little bit better. But anyway, this is the SWR. This is 14 down here. You probably can't read these numbers. And this is the end of the band, 14,350. So at 14,250, it has a perfect match. But if at 14.0, at the bottom of the band, it's like over 2.2, okay? So it's not very good in the CW part of the band. It's okay in the phone part. And the pattern also, the pattern's pretty good, like around even like 25, 30 dB. So at the best up in the phone part, but it's still not bad in CW. It's about 20, okay? So it's still not too bad, but not as good as you'd like, with some of the modern OWA type design techniques. And this is the free space pattern here, which would look very similar if it was up high enough on a tower. And this is for the phone setting, okay? Okay, so here's what I call the FET OWA mod design. And we get rid of this beta match, so that gets thrown out. It's a direct feed with just a bowing, 1-to-1 bowing. And then the elements, though, we need to add extra tips in here and change the tips. Everything else stays the same, okay? Pretty much stays the same, but the tips are changed, okay? And so that really improves. And then also the spacings are changed. If you look closely, these were all pretty much equal spacings on a 30-foot boom on the original design. Now we have this first director. It's only 20 inches from the driven element, okay, which is typical of the OWA to have the first director very, very close. That achieves several things. That achieves the direct 50 ohm feed and also achieves wide bandwidth. And you'll see the bandwidth is pretty amazing on this antenna. Okay, so moving on here. Okay, well, here's the model. This one I ran in Neck 4, but an Easy Neck Pro 4, okay? And then I used a package called Auto Easy that you can get from AC6LA, Dan McGuire. Very, very useful package. And Dan has a lot of great software out there. If you use EasyNeck, definitely look up. It's very inexpensive, and it really can improve a lot of the way you plot stuff with EasyNeck. Anyway, here's the new SWR, okay? I think most people would be pretty happy. This is the bottom of the band, 14, that's 14,350. Much improved, almost like a dummy load hooked up there, but this antenna is not a dummy load. And here's the front to rear, front to back, 30 dB, and it stays above 25 over the whole band, okay? And then the gain's about 9.5 or so. So it's, you could get a little more gain if you didn't use the OWA at a certain frequency, but to give up, you know, several tenths of a dB, it's worth it to get these kind of response, in my opinion. Here's some patterns. This is at 14, 14,150, and 14,350. So there's a 24 dB circle, 30 dB, 24. So it's, you know, it's really nice. Here it is over ground, and we're getting up to 14.5 dBi, and all the lobes are, you know, way down here in the region you'd normally be getting signals. And that was up at 100. He has this antenna up at 130 feet, okay, on a tower there, 130 feet. Well, here's some pictures. There's the antenna on the ground. And if you look in this picture, you can see how close, 20 inches, that's how close the first director. In fact, the driven element is slightly longer than the reflector. Okay, that's what gives you the bandwidth so wide. And here's the antenna up there. He has also a 2-element Cushcraft 40 up there. And that's Don, K4ZA. I know W2GD's in here, so there's Don's partner, and Don's up on the tower. He put this thing up. And then they sort of ran out of time that day, and I guess Don came back, and they were getting some interaction. And I said, oh, I did some modeling, and it was clearly the 40 was interacting with the 20. And so what Don did is he came back, and they rotated the 40 90 degrees, and the interaction disappeared completely. So there wasn't enough spacing here, and maybe even if it was a lot more spacing, there still would have been some interaction. But rotating at 90, that solved the problem. Okay, and there's a picture far away of the thing up 130 feet. Tom has about, I think, about 2 acres of land there. And Tom used his brand new rig expert, which I told him about. I said, you got to get one of these. And I tell everybody, get one of these. They're really neat. And this is called the Zoom model, which goes up to 55 megahertz, and it has Bluetooth. So you could even put this, you know, up at the antenna and then come down and use your laptop and run the thing from a distance. Anyway, he got this nice flat SWR. That's the whole band right there, pretty close to what the modeling said. And here it is outside the band. This is from 13 point, right here is 13.250 up to 14.750, okay, a 2-to-1 SWR. Here's the 20-meter band. So, you know, if you have an error of 50 kilohertz in the model and neck and FECO, who's ever going to notice it when you have an antenna design like this? So that's why, if you want to be perfect, you use FECO. Neck 4, definitely good enough for OWA type designs. Okay, so anyway, that antenna, Tom's been on with this big gun friendship net, and he's right up there. He's not quite as good as what we are on the mountain, and Tim Duffy with his 4 6-element Yagis, okay? But Tom is right up there with this thing, and he said the first week he had it up, he tuned up, it was a dead band, and he aimed it north, he called CQ, and he worked about 15 UA9s and UA0s at night on it. So he was sold on that. So that was pretty amazing. Okay, next topic. I'm going to talk about the WP3R station in Puerto Rico. And that got destroyed by Hurricane Maria, but in 1998, there was another hurricane called 1998, Georges. And Georges came around in September of 98, and we built this station in February of 98. And a student at Penn State, who's now KO9M, Jim Spence, he went down there, used to be KB3AFT. He did the ARRL, came in #2 in the world, okay, in March. And then I did the WPX phone, and I just did 15 meters single band and got over 10 million points for that, and set a North American record that held up for just about 20 years. And my score would have been in the top 5 if I would have went all band for the score, but I just did 15 meters. So this station played, there was no question. KE3Q, Rich did sweepstakes, both modes, 10 years in a row. And I think we only lost maybe once or twice on CW, but on phone, we won every year. And the record is still there on phone. And we think, even it was 80 sections back then, it's going to be hard to beat that record, but there's a challenge for somebody to go beat it. Anyway, this station really played, okay? And so I want to describe it a little. And then I'm going to show some HFTA of this station versus Angel moved to a new house now. And of course, this station was only used for contesting. He always lived away from it. But he put up a station now at his home, and he's doing pretty good. He was in ARRL phone and low power, and he came in #4, and he was only on for 24 hours or 26 hours in the last contest. So his station's playing pretty good too. Anyway, at WP3R, we had just an inverted V at 60 feet. It was just one tower, Roan 55, on a mountaintop. And the mountain was the highest hill in the whole area. All the way you looked, there was nothing higher. And on 80, it was another inverted V. 40, we used a wire Yagi that was aiming towards stateside. Mainly used that for sweepstakes and ARRL. We didn't really do CQ Worldwide there because we didn't have the antennas set up for going everywhere. On 20 and 15, we had an interlaced OWA Yagi that had 6 elements on each band on a 48-foot boom, separate feeds. And then on 10 at 30 feet on a tick ring, we had a 6 element on a 24-foot boom. And then Angel at his new house right now has an inverted L up about 60 feet on a tower there, one tower. He has a dipole inverted V at 60, dipole 40, 60 feet. So similar to what we had on 160 and on 80, everything else is different. And then he has a Skyhawk for 2015 and 10. And the Skyhawk got damaged in Maria, but did not get destroyed. It's all bent up, but it still works. So that tells you something. The Skyhawk, you may know, is the antenna that I did the electrical and Tim Duffy did the mechanical way back, and DX Engineering's still selling it. But anyway, that antenna is all bent, but I think Angel has pictures someplace on his website about it, but it's still working. And that's what he used in the ARRL recently. This is Angel and me having a good time at one of the great beachside restaurants there. And this is Pedro, NP4A, and me a few years ago. And this is up at a restaurant, Argentine restaurant near his house there. We like to eat down there too. And as you know, ham radio always travels on its stomach anyway. You can just see how big guys are at Dayton. Okay, this is the description of the station there. This is the 6-element interlace for 20 and 15 on a 48-foot boom. OWA, separate feeds. This is Nathan, NW3Z, Nathan Miller, who used to be in the Frankford Radio Club and now lives down in Maryland. He works for the Navy, but he was a Navy ROTC student here at Penn State. And I owe so much to Nathan. He was just a magician at making things get up in the air. And he did so much work at K3CR. And in 1 month, Nathan and some others, we were in Puerto Rico in February, and we built this whole station in 1 month, okay, down in Puerto Rico. And there's a lot of neat stories. We'd have to work early in the morning because the sun would get so hot. And Nathan's up on the tower, and every morning I had to buy cases of beer, okay? And each person drank something different. Like one guy only drank Heineken, that was Pedro. Another guy drank Budweiser, and then the rest drank the Puerto Rican beer. And so every morning I go to the local place when it opened real early and buy about a couple cases of beer. And that was how we got through the day, okay, building the station. And one time Nathan was up there and he said, I'm really thirsty. So we put on the rope, we put a 6-pack of beer and raised that up the rope, okay? And so Nathan got his thirst quenched. And then we would throw all the beer cans over the side of the mountain, because what better ground conductivity than beer cans? So there's about 10,000 beer cans, I think, on over this whole mountain. And that's probably the main reason why the station got out so good. Here's another picture. This is showing the 10-meter. It wasn't really mounted yet there on the tick ring at that time, but we mounted it later. We got it on the tick ring. But that shows it. This is 60 feet high and this is 30 feet high. Oh. And this is a view from up there, and you can see the ocean. Barely, probably. It's sort of hazy that day, but that's the ocean out. That's looking pretty much to the north there, and northwest over here, northeast over there. And you can see we're higher than just about anything on top of this hill. We were about maybe, I'd say 6 or 7 miles from the ocean. The whole island of Puerto Rico is only about 30 miles wide. So maybe we were 10 miles. This is looking down the sort of the entrance road. This mountain was about 300 feet above the road down below. And there you can see the tower and everything there. And it was 12 acres of land that I got. Here's just a close-up again. At the first time, we said from the same feed point, and we used to even have switch boxes up there, and we'd have one heliax running down and switch, and that got burned out from lightning so many times that we just ran a whole bunch of 6 lines, mainly heliax, 1 5/8, 7/8, and so we had all that going down so we could feed every antenna separately. And we had filters and stubs, and we had a 2 radio set up. It's sort of hard to do 2 radios, when you have the 20 and 15 on the same, but we did pretty good on that. And there's just another close up there. We also, this is a wire beam. We had a rope that went from the top of the tower to another hill that was to the northwest, and it was about 500 feet away. And so we had a big thick rope that was 500 feet and a support the tower at one end and a huge tree at the other end. And we hung this inverted V 40-meter wide spaced Yagi, and that thing really played fantastic. 52-foot boom, aiming right at Chicago. Everything we never had to rotate much, just kept everything aiming at Chicago, and that was it. Maybe the Maritimes you'd have to rotate to bring them in sweepstakes. And if you stood on the property, right at the cliff there, and you looked to the south, you'd see the Arecibo Observatory. So that's how close I was to Arecibo, and you could see how high we were up there. So we were pretty much the same height as the platform at Arecibo. So that'll give you an idea. But of course, hurricanes, we were lucky that Hurricane Georges, everything survived, and Hurricane Georges had 125 miles an hour. Nathan designed everything for about 130, and we've survived that. But Hurricane Maria was 155, and of course, we didn't survive that. Okay, so here's some HFTA stuff, okay, just to show you. If you're not familiar with this, this is the takeoff angle from 0 to 34 degrees. These are statistics to certain areas, okay? And this was statistics to Chicago area, which was a 330-degree bearing. And so the blue curve is at Angel's house, and the red curve is what we're getting up on top of the mountain. Now, this was on 160 meter. So remember, Angel has an inverted, well, I actually used a dipole, okay, because he originally had an inverted V before the inverted L. But anyway, this is what a dipole at 60 feet over Angel's property. Now, here's the terrain. Here's Angel's here. This is like 600, and there's 500. So there's a 100-foot drop there. So he has a fair drop off going stateside. He's living closer to the coast, so it drops off as you go down. And this is 300 feet down here. Here's ours though. Look at the steepness we get on our drop off. Okay, this is about 1,100 feet, and it's dropping down to about 700. So we got a 400-foot drop off in about the same distance, 4,000 feet, that Angel has about a 100-foot drop off. Anyway, we get some pretty good enhancement at very low angles. We're getting 8 dBi there on 160. Here's 80 meters. Okay, here's Angel's dipole at 60 feet. And he's, you know, in this region 0 to 10 degrees. Remember, it's always a lot of very low angle. That's why four squares do good. It's low angle is the key in propagation to a lot of places. So we're getting at about 8 degrees or so with just an inverted V on top of this mountain. We're getting about 12 dBi. That's about the same as a 3-element Yagi, and we're getting it at a very low angle. Okay, so that's a tremendous enhancement. And we're doing pretty good even up at these higher angles. You see the distribution there. Here's at 40 meters, and now we do have the 3-element, which I modeled as a 4-element because it's wide space. Here's Angel, okay. He's somewhere down around 0 dBi in this region, these low angles, and we're up at like 17, okay. So that's like a stack of Yagis, okay. And we're getting like a stack of Yagis with just the one Yagi because of the terrain enhancement. It's pretty tremendous. Here's 20 meters. Now we're using the 6-element at 60 feet, and Angel's using the Skyhawk 3-element. And you see here, we're getting a little over 19 dBi. So that's pretty close to, we got a little bit more than that with the 3-stack at K3CR with the top antenna up 180 feet, okay? And this is just a single 6-element, but using the mountain. And look at that low angle. We would have never got this low angle at K3CR, okay? Because we were over pretty much flat ground. Angel's getting a typical 3-element pattern. He's getting up to about 13 dBi, and he's up at about 20 degrees or so, okay? So the gain advantage of our station was tremendous there, if Angel would have been on at that time. Here's 15. Now 15's really good at this super low angle. Japan would have been unbelievable, but we're losing some in this region, okay? We're down less than a 3-element right in here. So that probably was not the best height. even though 15, we did good on 15, just because we're Caribbean. But, you know, this, if I would have knew this at the time, I would have explored. Angel's actually beating us here, okay? And he's up about the gain of a 3 element, 12 dBi or 13 dBi. That's on 15 meters. And here's 10 meters. 10 is fantastic. Again, we got, look at this statistics, and we got this whole range covered. Beautiful at 16, 17 dBi, okay? With a 6 element at 30 feet clear down to this low angle just because of this terrain. And now Angel's not bad, but he's in the region of a 3 element, okay? Definitely lower angle for 10 meters, but you know, he's not exceeding 14 dBi there. Okay, here's the Europe. So there's 160. Again, we have pretty good advantage, but we're not getting too much gain. We're up about 5 dBi, about the same as a 4 square. 80 meters, we're up about 10 here, but we're up at a sort of higher. We're not getting a whole lot of low angle enhancement here. We're mainly up at around 15 degrees, but that's still probably pretty good to Europe, but we're getting up about 10 dBi with the dipole. And there's Angel there with his dipole. But 40, we're starting to come in. If we add the Yagi aiming to Europe instead of fixed to stateside, now we're getting up 17, 18 dBi, but we're still not getting quite the enhancement because you see the slope is not quite as steep. We're not quite as steep. Angel's almost on flat ground, you might as well say, for what he's using. And so having this not drop as steep as what we had on the other bearing, this is at Europe at the stateside, we're not getting quite the low angle enhancement. But on 20, we are. 20, it's getting a real good. We're up at 18, 19 dBi at very low angle. Here's Angel again, pretty typical. Yeah, 3 element Yagi, 12 to 13 dBi. And at 15 meters, we're getting pretty good here. We do have a little bit of notches, but very, very low angle to Europe here, which would be really good. We're up at 18, 19 at the super low, and even 14, 15 here. So pretty good again. Angel's actually not too bad, but he's not getting much above 13, 12, 13, 14. But definitely lowering as you go up. And 10 meters. 10 meters is fantastic. Remember, we're only 30 feet up, and we're covering this super low angle, which statistics are really there at the low angle to Europe. It's up over 18 dBi, okay, with a single 6 element 24 foot boom Yagi. Angel's getting pretty good too. He has some enhancement here, and he's getting up about 17 with the Skyhawk at some of these low angles, right where he wants it. So Angel should be pretty competitive on 10 meters, okay? So let's look at this problem at 15 again. If I would have had this software back then, here it is again, what we had at 60 feet on 15, and this is to stateside. And just look what happens. If I could have lowered the height down to 40 feet, this is what we would have got. It would have just filled in everything, and that would be the pattern you want, 17, 18 dBi over this whole range here. And there's what you get with just the dipole at 60 feet, okay? I put that in over flat ground just to show the difference. So we were too high, clearly too high, and Dave Leeson talked about this a lot at his mountaintop, that you can get too high and you'll get stuff like this. So this would have been much better if we could have been at 40 feet, but only for 15. Now let's look at 10. Suppose I would have said, let's put 10 up at 60 feet. Here we are at 30 feet, beautiful pattern, okay? A really good gain. Here's what would have happened if I would have went to 60 feet. It would have deteriorated. I wouldn't have been much better than a 3 element Yagi in this region. Maybe some real low angle at there, but statistically, how many times you're gonna have angles that low? So 30 feet, and I just guessed at it, you know, the way we did the tower and everything. We guessed pretty good. 30 feet was pretty good. And I think 60 feet for most of the stuff was pretty good too from that station. So that helps to explain why that station was so competitive and so strong of a signal. Okay, where did all this HFTA come from? Well, it turns out before HFTA and something called TA that Brian Beasley did, we did a project for the Navy when I was at Penn State, and it was helicopter measurements in Utah where they were interested in the effects of irregular terrain at HF, just exactly the same what we now are interested in as hams as HFTA and TA and so forth. But there was no HFTA then. There was not any kind of way to solve it either. So we used helicopters, and we used these antennas, 3-axis antennas that you could fly as a drone behind a helicopter. And of course, it cost a lot of money, as you could imagine, and the Navy paid it. And we flew a lot of days out, and we put in dipoles and monopoles on the flat ground in front of a hill. We put it on top of a hill, and we put it down in a valley behind the hill. And I wrote a bunch of papers, and I called up Brian Beasley and told him about it, and he came up with TA. And we figured out how to model this with using some software and some technique called the geometrical theory of diffraction. And it was never used at HF before. And I said, let's just try it. And it worked. And we got such good results of the modeling versus the helicopter measurements that I called out Brian and said, hey, Brian, you gotta come up with this terrain modeling. And this, here's how all the equations and how you can do it. And then I called Dean Straw and told Dean about it. And he came up with HFTA, and Brian came up with TA. And so these measurements really was what originated all this terrain analysis for ham radio. And we can be happy that the Navy did it, and happy that I tried to use a technique that was never used at HF, and it worked. Okay. Well, here's just an example of again, showing what you can get with enhancements. This was actually some, these results I took, the models we did out of Utah. This is on top of a hill and then over flat ground. But I just took a 10-meter Yagi and said, if we had that 10 meters and we converted to our frequency we use, which was 27.7 megahertz, what would we get? Okay, and here's what the high gain 105 CA would do over flat ground. And you can see it's, 13, 14, maybe even 15 dBi there, okay? Maybe even 16 if I look at these numbers here. So that's what you get over flat ground, okay? So maybe 15 to 16 dBi. Here's what you get if you put the antenna up at 106 feet, okay? And so you don't really get much more gain, just you get all these lobe splittings, okay, when you put it up there. So here's the hill now, and we're up at 106 feet above this hill. And you're still not getting much above 15 to 16 dBi. Here's what happens when you bring it down to about half that height at 53 feet, and still you're not getting much above, what you get, especially down, you might get some lower angle there, but one lobe sticking up, but it's still not the greatest pattern. You got gnawing occurring and so forth. But look what happens next. When you put it at 34 feet above the mountain, now we're up to 20 dBi. Okay, so we've really enhanced the gain, and it's a nice big lobe right where you want it for low angle propagation. So that's very, very important. So that just shows that you really need the model. This was all modeled with TA, which is Brian Beasley software, and HFTA shows the same thing. Okay, so that just shows you that being too high on irregular terrain can be a real detriment. You really need to know what height do you want to be at. Okay, I think we have a little bit of time left here. Let me talk about this new station we're building. We call it Camp Kilowatt and or Camp K. We're probably going to use the call KC3R. People that I've talked to in this big gun friendship net have said the signals are so strong from here that we're calling it the Magic Mountain. And then the dipole I have on 40, they call it the Magic Dipole because it's getting, you know, tremendous reports from the enhancement like we're seeing what we had in Puerto Rico. So HFTA shows incredible terrain enhancement. Here's the hands that we're all working together, putting all our resources. N3EB is Eric, and with K3ARL, they own the really largest communication company here in central PA, have a lot of 911, police, fire tower sites. And one of the 911 sites Eric saw was for sale. It's 40 acres. And he bought it. He said he has to buy this thing. Okay, here it is. Here you can see the land we have here. Here's a topography, and it goes south to north where the flat part is. And here it is here. And so you put your antenna here, and here's Europe. You're going out over this valley to Europe. It slopes down to the north to India and Asiatic Russia. It slopes to Japan. You'll see a drone later. It's perfect. That I know there probably are other mountains like this in Pennsylvania, but this is just too good to be true for ham radio. Anyway, we also have some others. Mark K0LO. He's a retired RF engineer, owned a company here in town that built a lot of amplifiers. He's excellent at RF and networking. We have Mark NKAQ, also a tremendous RF engineer. Works at RF in State College, also a member of Frankford. So I guess this is our connection with Eric and Mark to FRC. And I guess we'll be putting scores in for FRC in the future for this. And I know they put some in already. K3CR, we always put it into North Coast Contesters because Tim Duffy and I are such close friends, but I think Tim will understand. And then Greg, K3GEM, who has a lot of experience too with networking and stuff. Anyway, the problem on this mountain is shown here. Okay, this isn't an actual picture, but it could look like this up there. And Eric says it has looked like that. That's rime. And then you get clear ice as well. They're both equally bad probably. Rime just keeps building and building and building, and clear ice, you know, that's heavy. So these are big problems. Wind is big problems on a mountain. Lightning are big problems. So we got all these issues. So having this nice mountain with great signals, it's great, but you gotta have this or it's not gonna last, okay? It's just like putting up an 80-meter beam. You're fighting Mother Nature all the time. So Eric said, can you design me an antenna that can handle the ice? What happens with ice, like I said, is ice will always shift, and I'm sure all of you have had ice on your antennas probably at some point. It shifts the operation of the antenna down, and it can shift it below the band, and then people use tuners, but they don't have the performance. And so I came up and really optimized a lot. And I was able to come up with a design that goes well above the band. And so even though it will shift down, we're still going to be fine. Well, Eric, N3EB, he likes to do things in a big way. Okay, and you'll see pictures coming up. And he goes, maybe for us, for him, it's normal. For us, it's sort of what I call overboard. But he really built a super, super strong Yagi and tower and anchors, and everything's to the limit, okay? And so we used Yagi stress in the K0 or K5GO software, And Eric came up with the design, and I did all the electrical and kept changing things. And he came up with a design that can take 1.5 inch radial ice. So that's 3 inches diameter, okay, of ice. And if the element had no width, so it's even bigger if the element has width to it, which these elements do, and it can handle 44 miles per hour. He said usually when there's rime and ice, the winds aren't usually that strong, not much over 40. So we think we'll probably be okay. With no ice, the antenna handles 165 miles an hour, okay? Now, there's nothing you get for free, and so the penalty is weight. This antenna is 6 elements on a 52-foot boom. It weighs 450 pounds, okay? And so there's going to be 3 of them up there, so you can do the math, okay? It's like 1,400 pounds on that tower. The SWR is less than 2 from 13.25 to 14.95. It's less than 1.5 from 13.75 to 14.9. Okay, so it goes way, way above the band, and I'm going to show all the performance of it here. Okay, as I said, Eric does things in a big way. This may look like close spacing, only 40 feet, but that's what HFTA likes. HFTA likes close spacing when you put a stack. And so we're going to be at 44, 84, 124. We've put the first one up at 84, and we got 2 more. And we have a K0XG ring rotator. And here's the tower here. This is a solid round member tower. And there's a ring at the top, another ring here, and another ring here. Okay. Here's what these rings look like. They're big. And W2GD, he knows these things inside and out in his sleep, because he's worked with them so many times. They'll turn anything. I mean, these things are brute force. They'll just turn anything. Tick rings are little babies, and these are the big brothers, okay? These things are amazing. This is a tower here. It's solid round member. Eric likes big anchors. So these are I-beams in the ground, okay? And they have back supports, and we're using real steel guy cable and insulators and all that. The K0XG doesn't use pots. It uses this thing that's called a pulse counter. And so the motor, this thing spins very, very fast, and it's a magnet, and then there's a Hall effect sensor here, and that counts pulses for the green heron rotator. Eric knew that he had to clear out a lot. There's so many rocks, and it's all rocks up here, and running trenches and digging, holes and stuff. He went out and he bought this excavator. So, and he loves it. I think he loves driving this more than operating ham radio. But anyway, he just has so much fun. He's like the little kid, driving this thing around and digging holes and putting rock piles everywhere up there. Here's a couple guys that are up on the tower there. You can see them. There's also another tower. That's the 911. That's how Eric found this property, because he serviced the 911. And then the property was for sale. And the people at the 911 allow us to put up some antennas on this. So clear at the top at 180 feet, we have an inverted V on 80 meters. And at 100 feet, we have an inverted V on 40. That's the magic dipole, okay? And the 80 meter, I think, is even more magic on 80 meters when I work Europeans. But that's just broadside to Europe, and it's amazing. Right here, this is the top of this tower, and right there is a ballon and the coax hard line there. And you can see we're feeding it there. So that's clear at the top, right by the strobe. Eric had to go by, the other strobe was too noisy, so he went out and bought a new strobe, and we don't have any noise anymore. Here's just some more pictures. Here's the rock piles, okay. Here, this pile here of all this aluminum, this is K3CR. And we had three 20-meter Yagis, 6-element, 48-foot boom. Everything was 48-foot boom. We had three 15-meter 6-elements, four 7-element 10s, a 4-element 40, and other stuff. But that's all the aluminum and stuff. And we're probably going to convert some of the 20s to 15s, and convert some of the 15s to 10. And I have a guy interested in buying the 4-element 40, which cost $8,000 new. And so we're going to give a good deal to him. Eric also, for his trenches, you know, where he has to run conduits and so forth, he wants to be able to go down inside. And if he has to do something in a cable, he wants to be able to climb a little ladder down. So he's putting these manholes in everywhere and running trenches and conduits to the manholes. So we're going to run the cables. This here, we think will be the 40-meter tower for the rotatable Yagi. That's a pie rod, and it's about a 30. I think it's 36-inch face or something like that. And so that's 140 feet of pie rod there. Excuse me. Here's the 6-element with the crane putting that up. Here it is again, and we're putting it up on the middle tick ring. And there's just another picture far away of the tower and the Yagi up there. Here's the manholes for running conduits to different parts of the property. Here's a manhole here, and you can climb down in there, and here's conduits, and he's running water through there and all kind of stuff. Here's the conduits here. Here's our amplifier from KC3R here that we use. And I don't hear any laughs. That's right, you're all muted. So, no, that's not. That's another story. Somebody played a joke on me, and some guy in our group on this Big Gun Friendship Net, I was put on an email accidentally, and one of the guys said he was getting his amplifier, something burned up, and he was getting it fixed, and they were sending it back, and they had his call on it, and I thought, oh man, this guy's running like 25 kilowatts. That's a 25 kilowatt amplifier. And it was all a joke. And me and some other guys, they got us. They thought that, you know, we thought that this guy was really running this thing. And it turns out he's not. He only runs 1,100 watts. But the Magic Mountain pulls the signals in so good that I thought he was running something like this. So I put that. Here's what we're running. It's a Flex 6600. And a KPA 1500. I usually run it at 1,400 watts, okay? You can't run it at this kind of power. And there's our building right now until Eric builds some other stuff. That's an old cable TV blockhouse, and that's where we have the remote station and where we're gonna keep putting more stuff in there. Okay, well, here's some modeling results. Here it is. You can see this is only 17 inches, okay, on this antenna. And here's the SWR. FECO is the red, that's the model. And then the measured on the Rig Expert is the green. This is 14 megahertz, and that's 1.5, that line. And you can see we're all under 1.5. We're actually getting a little bit better than the model predicted. We're going up a little bit higher, and going up past 14.9. And so that's really beautiful SWR. If you go outside the band, here's the 2-to-1. It's, as I said before, 13.25, and we're getting up to about 15, okay? And so that's what the measurement and the model shows. Here was NEC and FECO. Remember I said on the 80 meter, was a little shift. You can see NEC is always shifted a little bit down in frequency, and FECO is usually pretty on, especially on the upper side. And here again, the FECO is the red and the measured's the green. But if you look below the green here, which is the measured, it's agreeing a little bit closer with NEC. So I would say NEC 4 is actually better a little bit below the band, and FECO's better above the band. So if you build your antenna in the band and you make them wide band designs, you're going to be on whether you use either code. So that's the main thing to notice, take away from there. Okay, here's some patterns with the stack. This is over flat ground. And you can see here's the patterns we would get. This is at 14, 14.1, 14.2, and there's 14.3. Okay, so it's pretty well, you know, super lobes, everything. Now here's at 14.4, 5. I skipped 6. Here's 7, and here's 8. And you see we're still at 20 dB. All the way up to 14.8. So when the ice comes, we'll get these patterns, you know, maybe in here someplace it will shift down. When there's no ice, we'll get these patterns. So no matter what the ice does, we should be okay. And so that's the main thing. Here's the azimuth patterns, again, the same frequencies. And you can see here's at 14.8, 20 dB down, 20, 20, 20. And there's 30, 30, 30. So we should be good. This antenna will play even with ice. Okay, let's see what happens when we put it on the terrain now. Here it is on the terrain, the stack, and there's the terrain we have. Compare that to Puerto Rico. This is up at 2,200, I guess, is the top, and goes down to, like, you know, 1,500 here in the valley. Here it is. Here's what the stack would do over flat ground, the green. Here's what the single antenna we have now would do. And here's what happens with the stack. We're getting up to like 22 dBi. And it's all in this real good range of angles. Okay, that's the Europe. Here's the Japan. Again, look at the terrain to Japan. This mountain is perfect, okay? And here's the stack to Japan on flat ground. Here's our single Yagi in red. And here's what we get with the stack, 23 dBi, 22, so forth, all in the good range, okay? So we think the stack is really gonna play when we get this thing going. Oh gee, Penn State again, okay. Okay, I wanna just mention one other thing here, and then let me show some of the drone. I think we're okay on time, I think. I know I usually go past 9 o'clock, so I'll try not to go too much this time. Anyway, we decided to put, as I said, a 6 meter antenna. We just wanted to play with 6, so we ran some 7/8 inch heliacs up, and that's running into the Flex 6600 and through the KPA 1500. And so anyway, I decided we want to put something up there that does not interact with the 20s. And so let's just put a real tiny antenna, 8-foot boom, 4-element. We'll sort of scale it from the 4-element 40-meter OWA, which was the first OWA Yagi that I ever came up with for Tim Duffy. And I made all the elements for ice. We just made them 1 inch constant diameter. That's real easy to model with any code. Even Nec 2 does perfect. We put about 12 ferrite beads for a balun, and direct feed 50 ohm, and we optimized the Yagi just like I do for 40 meters, okay? Well, here's the dimensions of it if you want to go build one. I think in some ways on 6 meters, a low gain Yagi is something good to have, because, you know, when you have super high gain, like I designed a 13 element on a 65-foot boom for NP4A. And of course, when he has that aiming at somebody, it's like fantastic, but the front to back was so good. I designed a 9 element for 9K2 GS Abdullah. And he said, it's unbelievable. It blows away M squared and JK. And anyway, it's so sharp though. It's like a laser beam, and the side lobes are 40 dB down. And so you don't hear any stations in other directions. So I think a wider beam Yagi is good to have, and then switch to the high gain. Anyway, this is it here, the driven element. And so that's all the dimensions. There's a model of it. There's the SWR. really super OWA. This is from 50 megahertz up to 50.5, okay? Just a perfect match. There's the pattern, free space, 30 dB down, that's at 50 megahertz, 50.3, 30 dB down, 50.5, pretty close to 30 dB down, okay? So pretty nice, clean, wider beam, so you'll hear stations better where it's aiming, and that's it, okay? Oh, Penn State again, okay. So let me show some videos now again, and some drones here, and we'll see. You'll see some video of this site. Okay. There's really no sound on these, so I'll just do some talking on it. Okay, let's show the first one here. It was made in July. If somebody wants a shout out, can you see the video?
Yeah, we see it. Yes. We see it fine.
Okay, great, great. There'll be just a few minutes here, and we'll be pretty close to 9. Okay, so that was going up from the site. This is looking to the southeast, okay? Now we're swinging around towards the east, and right down through this valley, this is to Europe, okay? Right through here is Europe. That was the 911 tower. Now we're looking north here, that's north. Here's the tower, there's the 6 meter, and this is pretty much north, a little bit northwest. This is, the road goes right to north. You can see how the land drops off. This tower, it's all been regalvanized. And this is one of the K0XG rings. He sells them with, he just puts a PVC pipe. W2GD will like this. We made our own custom aluminum covers. They're welded on there and so forth, or clamped on. And so we think this is a lot better than PVC pipe. And you can see the terrain, how high up we are. Eric's going to bury all this power line coming in. He hasn't got to that yet. But we don't have any noise. This noise is so low up there, you just can't believe it. That's the 4-element 6 meter, turned by a Yaesu 2800 there. And that's a K0XG at the top. Notice no guys at the top, okay? Eric didn't want guys up there. And I'll show you what he did when we get down a little lower. Okay, down lower, what he did on this part of the tower, here, down here are the guys right below the 20 meter. This is double legs, double solid legs on every leg, okay? And he had those welded on and galvanized. Notice 2 3-inch booms. There's no truss. Everything's supported by just booms. So it's 2 3-inch booms. And here's a K0XG. Again, our custom cover, the W2GD. This spacing here is 17 inches between those elements, okay? And this is the ballon, that's 40, number 31 beads, similar to K3LR, and DX Engineering sells these standoffs now. And so there's no extra connectors and things that go wrong in a ballon. It's just the coax going straight to the driven element. And so you can buy this whole thing from DX Engineering. This is the reflector back here. Everything is aluminum here, plates, because we wanted to make it stronger. And these are those resin bulkhead mounts for just the driven element. And I took this into account. It changed the length of the tips. We adjust the center. We didn't adjust, all the tips are the same. We do the adjustment from the center element. It's easier. And I had to change the length by 5/8 of an inch to handle the effect of these boom element clamps. Very little effect. On an antenna this wide, we wouldn't have had to do anything. See the rock piles down below here. And these are those fiberglass rods here to go to the guys. That's 7/8 inch heliax up to the 6 meter. So it looks like a little 40 meter for W2GD there. And you can see how high up we are on the edge of this mountain. It's really perfect. Don't get dizzy here on some of these shots. There's a 911 tower. And on this tower, we have a 40 meter inverted V at 100 feet. We have a 80 meter inverted V at 180 feet at the top. And we have a rope that goes clear out to some tall trees way out to the northeast. And hanging from that rope is a 160 meter quarter wave wire with 8 elevated radials. And so that's what we use on 160. There I think you can see some of the wires here for the 40 and the 80 coming off the tower.
Hey Jim, what is that box that's sitting underneath the?
That's a building, right? You're talking about here?
No, up underneath the 6 meter beam. That thing that you were saying.
Oh, right here?
Nope, right there. Yeah, what is that on the?
Yeah, that's the motor. Oh. That's the motor and the gearbox and the pulse counter are all under here.
In that tall.
Yep, this tall box.
Yeah. Okay.
And then the gears, are all around the ring and the bearings.
Got it. Okay. All right.
Yeah. Normally, when you see a K0XG, you just see a PVC pipe. He just uses a PVC pipe that he puts over top, and we didn't like that, so we said let's make our own custom covers. It'd be much stronger.
And what are those rotors?
K0XG.
Oh, so it's a custom rotator.
Yeah, he's a guy, Richard, that sells these. He also sells rotating towers. These things go for about $5,000 a piece, just to give you an idea.
Yeah.
But you can look up K0XG, and John W2GD is probably the world's expert in knowing how to put these up and, and take them down. This is the 911 center here. And so, there's a generator there and so forth, and the equipment for emergency 911, that's always operating. We were always worried this would have noise and stuff, but it's pretty well shielded. So it actually is pretty good. There's a generator for it, but we're lucky. And then we run that microwave dish, the lower one, that dish has a microwave link. Don't get sick here. That has a microwave link back to Eric's shop about 10 miles away. And so we have a special VPN box so we keep out any intruders. And then we can get into his system there, the VPN, through regular internet. That's the dish right there that showed for us. And there's his excavator. And there's his anchor. There's one of the anchors right there. Anyway, we get into the internet, into his shop, and then everything goes up on like a 1 gigabit per second link. So, and we run our own. We don't use the Flex system. We have our own network, private, and we use remote rig boxes to get the audio. It sounds a lot better than Flex, and so we use all that to get there.
Is it Flex gear, Jim? Well, most of it though.
We have so much stuff from K3CR. We have 5 K3s. We have like 4 Alpha 87As. We have several of the KPA 1500s. So I'm not sure. Right now it's just a Flex 6600 and a KPA 1500. But we got a lot of equipment there.
Yeah. And where is it, the operation? Where do you operate from, remotely or?
Yeah, from our house.
Yeah.
I operate from my home.
Yeah.
Okay. And let me show, and our plan is to be able to do contesting from the home. Okay. Let me show this next one. I think it's a little shorter. This was done more recently, about 4 minutes here. There's a guy that works for him that does the drone. He's not a ham though, so we would have wished he maybe would have took a few different kind of pictures. But there's the building. Here's the anchor right here. You can see the lower right. There's another anchor. Then you should see an anchor over there. But you can see this is a really nice location. This is like the ham dream location.
And what's the antenna stack plans in addition to those there?
Okay, we're going to put a 40-meter tower up. We'll probably put a couple of 4 elements up on that. And then we're going to put a fixed array. I have this super design. It's 4 2-element Yagis, believe it or not. And it covers very wide bandwidth, and just because of the way they're situated. And that's going to be fixed to Europe, very narrow beam, about 38-degree beam. And then we're going to be able to phase sideways so we can get another 20 degrees on each side. That will be fixed to Europe, and it's on a perfect spot. We're going to put it right where the slope drops off. And then we're putting in these magic receive arrays that are like 9-element receive arrays, but we're only worrying about Europe for those. And we have a lot of we have some 1,000-foot beverages up there now, and we're going to put stacks up for 10 and 15 also, and just keep going. I guess we're coming around to Europe now. That right up. That's sort of northeast, right up through this valley here. That's Europe. Okay.
Which automation platform are you using for switching?
We're going to design our own.
Okay.
Everything's going to be custom designed. And we've been really looking into that a lot, and how to design it the best possible way.
What prompted you to not go with what's commercially available?
Just more ruggedness, I guess. Instead of those little printed circuit board relays, we'll be using some bigger stuff, and just we want to customize it so we can be able. We want to have it so that we can have like 6 operations, 6 amplifiers to go to any antenna. And so we have looked at the Ham Plus stuff, but we think we can build it better ourselves.
I'm shocked to hear a ham say that.
Well, we got some pretty good engineers working there, so. That's the Europe. You can almost see the signals, when you're up there. You can feel them coming in. That's what I always used to say about the site in Puerto Rico. Now, if you look right there, there's the bowing for the 40, and there's the wire for the 80 for the inverted V. There's the insulator for the 40 right there. But those are just test dipoles, they're not, even though they're getting out like Yagis, very similar to K3LR, but they're just our test dipoles we put up. 80 though, they're real good for 80. We probably put some kind of wire beam to Europe on 80.
Okay. When do you guys plan? Are you going to be on the air for the fall?
No, well, we'd probably be on like some band, but not full yet. That's our problem is, we got, Eric has a lot of work at his company. Plus he does things so big of a way that it just takes time. We've been meeting, before the COVID, we were meeting, every week and coming up with designs of filters and designs of the automation and the networking and everything. And we still get together, but it's just a slow process to build a big thing and make sure it's going to stay up, and I keep telling Eric, I say, Eric, we only have like 15 or 20 more years, before we leave the earth here. And so we got to get moving. But anyway, I think we will. I think he's going to move a little bit faster. I just wanted to show, if it's okay, I know we're coming up on time, but I just thought I'd show a little bit of how this magic dipole performs in the Middle East on 40 meters. And I think you'll be able to hear this. So let me try this. And I'm going to zoom ahead to different spots. So you'll hear K8CX, another station that's in our group, K1DSK, me from the Magic Mountain using the Magic Dipole, K3LR using all three Yagis that he has on 40 aiming to the Middle East, and Angel WP3R with his 40 meter dipole. So let me see if this works.
Yeah, that's like Angel said. When Tim does it, it's always expected. It always comes out 100%.
That's fine,
there.
KHCX. Now look at the meter up there.
Yeah, Kel, I hope
like
all
S9, you can read it here.
legs come out good there too. So hope you're feeling good.
And now let me move ahead to me.
Here's the order.
Much too loud there, Jim.
And then
Let me
Mr.
turn that volume. I'm sorry, I hit the wrong button.
Jim.
Sorry to blow your ears
Angel,
out
Jerry,
there.
and Kel. So that's who we got here right now. So and also Jerry, great to hear you in. It was so great you could make the webinar as well. And Brother Cal, great on your procedure today. And
I'm sorry, there's K1DSK.
Give me a code. Antenna number 1, 1, 2, 3, 4,
Sometime
5.
like S8.
1, 2, 3, 4, 5. I switch.
Okay, and then I come in.
it's really great. Okay, let me
Head over a lot of times.
see here. I wanted to say also that Nick is listening.
Let me move up to Tim
Spirit,
Duffy
of course. At Arecibo,
There's Tim Duffy.
back as soon as possible.
Almost the
very,
same.
very
A little
sad
few more
about the
dB from
failure
Tim.
there, but I know you will come back stronger than ever. And
then here's
hello
Angel.
to Jim.
Oh wait, I went
Cal
to
and
Angel
everyone
there.
else. I think I said hello
About
to you.
S7,
Devin,
S8, S9.
thank you very much. By the way, Devin, the antenna 1, antenna.
Okay, that was recorded on a Flex at Alpha 71 Alpha Mexico. That's in Qatar, and that's safe. And he recorded us, and he's made a lot of recordings. But he's the one that said, "I can't believe this dipole is this strong," and he's the one that named it the Magic dipole. And then we always end our group there, this big gun friendship. Now we always end it. We stay safe. Stay safe with safe. Okay, so that's our saying, stay safe with safe. Anyway, he's one of the members that gets in all the time. But you could see the signal. Tim was only a few dB louder than that dipole, okay? And Tim was running an Alpha 77DX. It was actually K3 TUP's old amp. So I'm sure he was running pretty legal, and we were running about 1400 watts with the KPA 1500. Okay, one other thing, and then I'll be finished here. I just thought, if some of you haven't seen this is just one of the most amazing videos, and I will zoom through it too, but it's just an amazing video, and I think you'll get the idea when I show this. you notice 150 meters tall, 500 meters wide. And so what this is going to be, and I will zoom through it, but this is going to be a climb. They're going to climb up this thing. There's the beginning of the ladder climb. As they're going up on this thing, let me turn that volume down a little. As they're climbing up, you'll notice the dipoles. And I believe, I'm not sure, but I believe this might have been the receive array. I don't think this was the transmit array. And you also notice this big screen behind it. That's the reflector, because it was a big curtain array. You can see all the wires there. That's the reflector, and the dipoles are in front of it. There's the open wire line feeding them. Okay, let me zoom ahead a little. You can see the height this thing's getting. I know John would love to climb this W2GD. I don't know if he'd climb it in that kind of rusted condition. Okay, let me zoom up a little higher. Get in higher. Almost to the top. I don't know if I trust that fence on the side there. Or these ladders. I mean, look at the rust on these things. I think he's free climbing. He has to be, right? He's free climbing too. Almost to the top. There we are on the top of the woodpecker. I don't know what that is. Is that the escape hatch? Or look at the size of these dipoles and the supports they have. There's all the wires for the reflecting screen. Oh, I guess he wasn't at the top. Now we're at the top. Yeah, because now you got these observation decks still out there. There's the top of the world. Definitely a good takeoff there over flat ground. Now we know why the woodpecker was so loud. Yeah, look how high.
And Jim, what frequencies did that cover?
Well, I believe that covered pretty much. Oh boy, that's a good question. I think it covered most of the HF, but I'm not really sure. I'm sure a lot of people here have heard it. I remember hearing it when 15 meters was dead in the middle of the night, and then all of a sudden you'd hear it coming in like S9 plus. So I imagine it covered. It was over the horizon radar for detecting cruise missiles and so forth, and so it probably covered the upper HF region. I guess Bud in his previous work, but he'd have to kill us to tell us, okay, but he probably may know some history of what frequencies over the horizon radars covered. But anyway, I thought you might enjoy that, to see the woodpecker. That's I wish I could build a station like that, but anyway, thank you very much. It's been a great pleasure. I hope I'm there in person next time, and I hope we're all going to be there in person. So thank you so much. I'll be glad to take any questions. And,
thank you too, Jim.
Hope you enjoyed it.